Okay, Year 10, this is the work solution, video solution to HSC 2004, question 2. Now, the reason I'm giving you ones like these is I want you to put into place the skills that you've learnt with the distance midpoint gradient formula and the point gradient formula. So here's an example of a question from an HSC, and they give us some information here that we can put in. So first of all, they give us the coordinates of some points. So we know that this is the coordinate 1, -1 and 3. And this is the coordinate, I'm going to write it below because I'm going to have a whole lot of other stuff there, 2 and 0. Oh, that's a terrible 0. All right. Calculate the length of the interval AB. Well, you can either do a bit of Pythagoras here. All right, so we're calculating the length of from here to here. And if we wanted to, we could just go, oh, I'm just going to draw a right angle triangle here and here and go, well, that is 3 up, right? Because the y value is 3, and -1 and another 2 that way, so 3 across. It doesn't look like it. It doesn't look like it, but it is. It's not drawn to scale. So you could go, oh, AB, you could then go, oh, AB, so here's part 1. Part 1, AB equals the square root of 3 squared plus 3 squared equals 9 plus 9, 18. And I'd leave it as root 18. You can simplify that, and we're good at surds. We take the 9 out and get 3 root 2. However, and you can do that, but you can also go, well, I've got the 2 coordinates there, so I can just use the formula. And the formula is AB equals the square root, and you should have done a lot of these, x2 minus x1 squared plus y2 minus y1 squared. So what are the 2 coordinates? Well, let's write them. It was -1 and 3 and 2 and 0. And that's A and that's B. Let's just double check, make sure we're right. -1 and 3 and 2 and 0. Okay, so I'm going to subtract the x values. 2 minus -1 squared. So I'm just going, this is the x and this is the x and this is a y. Plus 0 minus 3 squared. Well, 2 minus 1 is 3, so I'm going to go 3 squared, and I'm going to get -3 squared. And you better keep that in parentheses. Well, 3 squared is 9, and -3 squared is 9 root 18, which we can simplify to 3 root 2. So 2 ways of doing that one. Find the gradient. Well, if you did this again, if you did this down here, and look, it doesn't look as though it's to scale. Remember, that's 3 and that's 3. It's going down. The gradient is the rise over the run, so it's 3 over 3, and it's going down, so it's negative, so the gradient's going to be -1. So you could do it that way, but I'm going to do it with the 2 points. So the gradient formula, remember, M is y2 minus y1 over x2 minus x1. And we've got our points. There they are. So let's go the y values first. And you've got to keep them in order, 0 minus 3 and 2 minus -1. Well, that gives me -3 on 3, which is -1. Beautiful. So we've got the gradient. What is the size of the acute angle between the line AB and the line L? Well, let's just get rid of some of this stuff. So here's the line L, and here's the line AB. Now the acute angle is this angle in here. We'll call that theta. All right, we'll call that theta. Now, if I go inverse tan, I will get this angle. Because inverse tan will give me the gradient. The angle. Inverse tan gives me the gradient of the angle in the x-axis. I could go, well, this is an isosceles triangle, 3 and 3, although it doesn't look like it. Therefore, this angle, because that's 90 degrees, must be 45. Therefore, that's 90, so this angle must also be 45 degrees. But I'm going to use the tan bit. So I want you to think about these things in all sorts of ways. So the one way to do that was to draw it a bit better to scale, and you would have got this 3, 3, down there, 45 degrees. Here's L, that's 90, so that must be 45 degrees. But let's use our gradient. So the gradient, tan theta equals the gradient. And remember, the gradient, the angle, is here. That's what it's going to tell us. Okay, so theta, oops. So theta equals inverse tan of the gradient. And the gradient is -1. And I get my calculator out and I go shift tan negative, come on, where is it? -1. And it gives me -45. Now, if it gives you -45, you have to know that that is is 145. 135, you peanut. Get back here. All right. And if you go, oh, sorry, and that's, I should have called that, well, I'm going to change this. I'm going to make that alpha. Therefore, because theta is, I'll change that. I'll colour that blue to indicate that that's alpha, and all of this is theta. So therefore, alpha equals 135 degrees minus 90, which equals 45 degrees. So there are two ways for doing that one. And that's a bit of a hard one. The next one, show the equation of the line. Okay, so let's get rid of all this stuff now. Show the equation of the line is that. And remember, we've got 1, -3, and 2, and 0. And look what we've got. We've got a line through those 2 points. So I'm going to use the point gradient formula. So this is question number 4. Remember, the point gradient formula is y minus y1 equals m outside of x minus x1. Do we have a point? Yes, we do. I'm going to use the point 2, 0 because it's nice and easy. You could use the other point. Do we have a gradient? Yes, the gradient is -1. So I put those in. Y minus a y value, 0, equals -1, x minus the x value, 2. Y equals -x plus 2, because I multiply that -1 there and that -1 there, and then I bring this and this back over to the left-hand side, and I get plus x plus y minus 2 equals 0, which is what they're asking me to prove. And we write as required. Now, write down the equation of the line L. Well, L is a vertical line. And if L is a vertical line, it means that x equals whatever the value is, x equals 2. The point C is on the line L such that AC is perpendicular. All right, so this is going to get a little bit harder. So I'm going to have to draw it. So over here I'm going to draw it. So there's my Y. There's the line AB. There's the x-axis, y, x. Here's the point, I'll put it about here, A, which is -1 and 3. Here's the point B, which is 2 and 0. I don't want to write that 2, 0 like that. Let's write it a bit neater. 2, 0. The line L is straight up. It's a terrible line. And there is a point C somewhere on this. So I'm going to write that Y because it's going to be in the way. There's a point C somewhere on this that it's perpendicular. So if I draw a perpendicular line from here and hit this point C, and this point C is going to be 2 and something. So the point C is on the line such that AC, that was silly. Let's get this line again. AC, so I have to come from A. AC is perpendicular. And it's 2 something. Now, how do I find this? Well, if it's perpendicular, I'm going to put the point C here. Well, if it's perpendicular, MAC, the gradient of AC equals the negative reciprocal of the gradient. Well, of the gradient, it's perpendicular. Because it's perpendicular to AB, it's a negative reciprocal. So the gradient, AC is perpendicular, so MAC is the negative reciprocal, the negative reciprocal. So MAB, if you remember, was -1. Well, the negative of -1 is 1, and the reciprocal of 1 is 1. So the gradient of MA is 1. The gradient of AC is 1. So now that I know it's perpendicular, and also that I know it goes through this point, so I've got a gradient. So I'm going to use a point gradient formula again. Y minus Y1 equals M outside of X minus X1. And I'm going to go, all right, well, what have I got? I've got the M equals 1, and it goes through 1, -3. So get the equation of the line. I go Y minus 3 equals 1, X minus 1. Sorry, it's -1 and 3. So -1 and +3. So that's, get rid of that. And minus 1. So I get Y minus 3 equals X plus 1. Y equals X plus 4. Now remember, all I have to do is find the Y value. I do have the X value, so I'm going to sub in sub in x equals 2, I'm going to get y equals 2 plus 4, so y equals 6. So the coordinates of C are 2 and 6. Or I could have used the gradient formula, because this has a gradient of 1. So the gradient of AC equals y2 minus y1 over x2 minus x1. And remember, the 2 points I have, -1 and 3, and 2, and I don't know what it is, let's call it y1. So, we'll call it y2 because that's where we're going to put it. The gradient is 1, we know that. So y2, which is what we're trying to find, minus 3 equals 2 minus 1. 1 equals y2 minus 3 over 3. Multiply the 3 across. 3 equals y2 minus 3. Add the 3 over. 6 equals y2. Hence, C is 2 and 6. So, lots of ways to answer these questions. Let's go back. So what did you have to do? Calculate the length. You could just draw a triangle and use Pythagoras, or you could use the gradient, the distance formula. Find the gradient. You've got the 2 points. Again, you can draw the triangle and get 3 over 3 and know it's going down, or you can use the formula. Show the equation of the line. That's easy because we've got y minus y1 equals m outside of x minus x1. Find the gradient. Yes, we know inverse tan will give us the angle, so inverse tan. And find the other coordinate. Sometimes it looks hard, but when you pull it apart, it becomes particularly easy.